Vivekji, please start.
Okay, thank you, sir. Thank you. Good evening, everyone. Today, I'll be starting with your next topic, which is research design. Now, what is research design? We talked about research. We talked about different methods we employ while doing the research. Now, the next topic today will be about the research design. Now, what actually is research design? Research. When we start doing the research, there are few things that we always talk about. The things we always we see how the research should be carried out. There has to be some detailed plan. There has to be some as we talked about yesterday, the aims and the objectives. So research design, as the word says, is a detailed plan of the whole investigation, which means research design is said to be the detailed plan of the investigation. Also, we can say that it is a blueprint of the detailed procedures of testing the hypothesis. So, in research, we've been talking about various steps where we talked about hypothesis as one of the important step where we put the research questions across, and on the basis of the research questions, we do statistical analysis, and we come up with the conclusion. This is what we've been talking about. This is what the quantitative research method talks about. Yesterday we talked about case study, we talked about interview, which are the qualitative research methods. Now today, as I just said, we will be doing the research design, which is a detailed plan of the investigation, or research design can be called as a blueprint of the detailed procedures of testing the hypothesis. So design, when we make a research design, when we make a plan of doing the investigation, when we make the entire blueprint of testing the hypothesis, we do say that what kind of research we'll be doing, what method we'll be employing, what kind of questionnaires we'll be using, what statistical analysis we would be using, and on the basis of the statistical analysis, we do the interpretation and we come out with the conclusion. This is what the whole research talks about. Now, research design, it helps the researcher in testing the hypothesis by reaching valid and objective conclusions. We make research questions, or we call them hypotheses, where we look into different dimensions by studying the variables, be it independent variable or dependent variable. We try to study those variables, and we come up with different research questions, which define how our statistical analysis will be done. So this is about the research design, where the researcher is always inclined towards testing the hypothesis. Hypothesis is such an important component while doing the research, because our research is totally based upon the hypothesis, the tentative solution that we look into while doing any kind of research. Now, research design has basically two functions. First, it says that it answers the research questions as objectively, validly, and economically as it is possible. Research questions or the hypothesis, they are very objective. They are very objective, based research questions, where we try to see whether, for example, if our hypothesis is trying to study the relationship between the two variables, we would say either it will be the null hypothesis. Yes, as I said the other day, the null hypothesis, we always make the hypothesis based upon the null hypothesis assumption, or sometimes we also choose the alternative hypothesis, which will be a directional hypothesis. So it has to be objectively, it has to be a valid, it has to be economically possible. We can't just assume an hypothesis, or we cannot just say that yes, a design is being made which is not a possible design. We cannot, obviously, when engineers make a design or a blueprint of the various strategies of making up of a car, how the car gonna be designed, what are the different technical aspects they would be looking. So that's what that's what we say in the research, that we have a design, we work according to the plan that we looking into. Now, the second is that a research design also act as a control mechanism. When we do a research, there are such some variables, there are some components which are supposed to be controlled. For example, if I'm trying to do a research where I am only putting, or I am only taking those candidates who have intelligence, as an average intelligence or above intelligence, so I'm controlling and trying to control my population by saying that yes, my particular sample needs to be only based upon those people who have either an average intelligence or above average. So I define it before I do a research. So somewhere I have to, when I'm designing a research, I need to control some variables so that it does not affect my research. Now, based upon control mechanism, there when we do a research, when we are collecting the data, there are few variances that come across in a research. The first is the experimental variance. Second is the extraneous variance, or we say it a control variance, and third is the error variance. Now, what happens during experimental variance, or what is experimental variance? Experimental variance is the variables that can actually affect my experiment. If I'm doing a research where I'm employing experimental method, the variance can actually act as a hindrance during my research work. Now, as I just give an example, that for example, I'm doing a research where I am just taking the participants who have above average or average intellectual people. There can be a possibility that some participants are not as per my criteria of selecting the sample. So that can actually act as an experimental variance, because they are not the part of my participants. They shouldn't be allowed for my study. But sometimes what happens during the experimental error or something, the variance can be countable, and it can actually act as an hindrance to the experiment. Now, next is the, yes, one thing more, the higher the difference between the experimental conditions, the higher will be the experimental variance. For example, if my aim of doing a research, say, is like, for example, that I am interested in studying how the rate of learning a task is influenced by the differential award, which means that if a reward, if I rate the learning task of the candidates, will it affect the reward or not? So I will put rewards under three different conditions. For example, high reward, low reward, and medium reward. So now, what happens during such research conditions, that there is a difference in the experimental conditions, because I'm providing three different conditions. One is the low reward, other one is the high reward, and third is the medium reward. So when we are rewarding, the participants based upon how they are performing on a task, it can actually act as a variance. That is why it says that the higher the difference between the experimental conditions, the higher will be the experimental variance. Now, next is extraneous variance. Now, extraneous variance is also known as the control variance. It is produced by the extraneous variables. Now, what are extraneous variables? Extraneous variables are those variables which can act as a hindrance between the dependent variable and the independent variable. So under extraneous variance, it is also known as the control variance. It is produced by the extraneous variables or the relevant variables. An experimenter always tries to control the relevant variables. As I said, we discussed it yesterday as well, that there are some variables which act as a disturbance during the research work. So we need to control those variables. If we control those variables, yes, the extraneous variance to some extent can be controlled. The third is the error variance. Now, the third function of a research design is to minimize the error variance. The error variance is nothing but it is defined as the other variances or variabilities in the measure which occur as a function of the factors not controllable by the experimenter. When we do the research, there are some factors which an experimenter cannot control. Therefore, those variables which cannot be controlled by the by the experimenter, they act or they are counted as the error variance. Now, there are some error variance, and these error variances have its own features. The first is that error variance is self-compensating, because sometimes the variability is positive and sometimes the variability is negative. Sometimes, yes, there are positive variations, there are negative variations, but it does affect the research as a whole. The error variance is both positive and negative. It tends to cancel out in several repeated measures. For example, we used to study in mathematics that plus and plus will always be plus, minus into minus will always be plus again. But if it's plus and minus, it will be a negative. So that's what it counts over here, that the error variance, if it's plus, if it's a negative, it can be negative, as well as the positive error variance. Now, error variance is unpredictable, probably because it is based on random errors. When we do the experiment, sometimes what happens is, the variances are actually uncontrolled, and therefore they become as the error variance during the research. Now, the next topic is about the research design. The first thing that we'll be doing in research design is a single factor design. Now, what is single factor design? Single factor designs, as a word says, is a word where we take one variable at a time, but we're trying to study the variable as a whole variable. When we tend to do a research, the first thing we do, we have to do, is to decide what research questions we want to find the answers to. It's very important, as we have been talking, and that's what the base of the research is, that the research questions needs to be formulated, they needs to be answered before we before the research is actually finalized or carried out. The second is, having decided our research questions or problems, have to decide how to go about finding their answer. We do, yes, find out the research questions, and on the basis of the research questions that we have formulated, we do apply the statistical techniques to it as well. So that's what, again, the second main function, or the characteristic of a single design research method is. Now, there are basic terminologies in research design. The first one is the factors, the second one is the levels, and the third one is the treatment. Now, what are these? Factors are nothing but the variables that we are trying to study. Now, under variables, for example, if light is one of the variable, light can be, it can be the volume, or it can be dimmed out, it can be increased, the level of the intensity can be increased. So what is happening over here, these are the different levels under the factor. Every factor will have different kinds of levels. It depends upon, again, variable to variable, what factors are we trying to study and what are the levels under such factors. And third is the treatment. The treatment needs to be given as well. Okay. um, am I going fast? Just need to ask a quick question. Am I going fast or am I fine?
Yes, sir.
What, yes?
You are going so fast, sir. We are not able to even listen what you are saying.
Ma'am, actually, the thing is, if I don't go, if I think I'm going okay. I know I'm a bit fast, but if I don't do that fast, I won't be able to finish things.
Okay, sir.
But I'll try to be fine. I'll try to be slower down a bit. But yes, to do all those stuff, I need to be a bit fast. But I'll try to be slow down. Sure.
Okay, sir. Thank you, sir.
Well. Okay, now the next is, yes, we were talking about different factors. We were talking about the levels and the treatments. Now, factors are the independent variable of an experiment. They become the factors. As I said before, as well, there are variables that needs to be considered. There has to be factors. There has to be variables which we try to study. Yes, it has to be either an independent variable or the dependent variable. Under different variables, there are different levels. A level is a particular value of an independent variable. Now, an independent variable have at least two levels. When we try to study the different levels, it has to be at least two levels, because otherwise it won't be counted as the level. If you're trying to study only one level, it won't be counted as a level. So in order to study the level of the research, it has to be at least two levels that we are trying to study. And the third one is the treatment. It refers to the particular set of experimental conditions. What treatment are we going to do? Yesterday I talked about a meditation which can be done with the participants, where I'm trying to control the exam anxiety of the students. So that particular meditation is the best example that can be quoted while talking about the treatment cell. Now, the next is a single factor design. Now, under single factor design, there are two. First is the between group design, and second one is the within subject design. I repeat, there is a single factor design that we'll be talking now. Um, and under single factor design, we have been there has been two categories. The first is the between group design, and second one is the within subject or within group design. Now, between group design, under between group designs, there are two particular groups that we will be talking about. The first is the two randomized group design, and the second one is the multi group design. Now, yes, we are discussing the third book of the research methods, which is the research design. Yes, page number 8. No, between group design, as we say, between group design has two particular designs. One is the randomized group design, and the second one is the multi-group design. Now, under two randomized group design, as the word says, we have two different kinds of groups, or the factors that the levels that we talked about before is what is being the different group designs over here. When we are doing two different kinds of groups, when we are when we employ two different kinds of groups under excuse me, under one study, we call it a two randomized group design, because we randomly make it on the basis of certain aspects when we make the group. For example, I just give an example that I want to study the participants, or I want to study a group which needs to have the participants who have, for example, what we call personality characteristic. For example, I want people who are extrovert in personality. So I'm giving one particular kind of a direction that my participants should be based upon extra about this particular personality trait. So if not, that can become as an error variance in the group. So two randomized group design includes two groups that can be that can be put under our design, and therefore we try to analyze, we try to interpret, and we try to work on two groups. But sometimes what happens is we have groups or our research is basically focused upon, where I'm trying to study more than two groups. There it will be the multi-group design, where we have I'm not trying to study. My focus is to study not just two groups, but many other groups. It can be three, it can be four, it can be five. Therefore, my treatment would be different. My factors would be different when I'm trying to study, and my levels would also be different when I'm trying to study the multi-group design. It entirely based upon the researcher how many groups they would be including in the research design. Now, next is the within subject design. Now, within subject design, there are two conditions within subject designs. We have factors. For example, my research design wants to include the participants who are from different conditions. For example, one particular group is from the participants, or include the participants who have been taught by presentation. The second group would be people or the participants who have come from blackboard presentation. So these are the different groups who have come from different conditions. Their conditions are different. They have been belonging to, or they have been the group of different conditions. So when we say different conditions, they are from two different conditions. Then we say two condition within subject design. But there can also be there can also be conditions where the groups or the participants are from not just two conditions but from three conditions. For example, blackboard presentation, or the PowerPoint presentation, or third, it can be presenting through voice. So there can be different researches where the participants can be employed, participants can be put across from not just two conditions, but from the conditions more than two. Then we call them the multiple conditions within subject design. Now, yes, the treatments can also vary. The subjects can also vary. The number of the subjects can be different. For example, in group one there are 13 participants. In group two there are 15 participants. So the number of the participants, if it differs, does not matter. But what matters over here is the treatment that we giving to the subjects should be equally distributed. Now, next is factorial design. Now, what is factorial design? We just talked about the research design, where we either talked about the single design, we talked about within subject design, within subject design, we talked about people or the groups based upon two conditions, or we talked about groups based upon the multiple conditions. Under factorial design, as the words say, the factors are accountable when we design a research. Now, for example, the factorial design is one in which two or more variables or factors are employed in such a way that all possible combinations of selected values of each variables are used. For example, there are different variables. Under different variables there are different factors. Now, there can be 2 by 2 factorial design, there can be 2 by 3 factorial design. Now, when I say 2 factorial design, it means if, for example, I have factor A and factor B. Okay. Now, factor A will also have two components, and factor B will also have two components. So when I say both the factors will have equal number of not the equal, but two over here, two for factor A and two for factor B, therefore we call it a two factorial design. But there can also be that yes, my variables have more than three sub factors. So that in that case, for example, it will be called as a 2 by 3 factorial design, where my factors are A and B, but under A factor I have three sub variables, where I'm calling it as A1, A2, and A3. That is what is defined as a 2 by 3 factorial design. So we design according to what our desire is, what our aim is, what is our objective. Every researcher who is trying to do a research will have its own way of doing the things, the way of treating the treatments, of controlling the variables and doing a research. every researcher will have its own aims and objectives and hypothesis, and based upon that, every researcher will have its own way of doing the things, whether I need to put whether my conditions or the groups or the participants will only be put into two conditions, or will be they put into three conditions. So depending upon what the researcher is actually looking into, sometimes what happens is our research is not just focused on one particular group. Our research might be focused upon more than two groups, more than three groups, more than four groups, or my research would be focused upon giving more treatments. For example, not just giving treatment to two different groups, or three different groups, or four different groups, but to many groups. So it's entirely based upon what are we trying to do, why do we trying to do, what how many participants do I need, how many groups do I need to take, how many treatment do I need to give. So it entirely based upon the researcher to researcher, how many factors the researcher is aiming to make. Because obviously if someone is trying to look into three different factors or three different groups, he has to make three different groups, because that's what his intention of doing the research is. Am I clear till here to everyone? Should I go ahead, or any question?
Excuse me, sir.
Yeah, please.
Good evening, sir.
Very good evening, ma'am.
Sir, can you explain two by third factorial design again?
Okay, sure, ma'am. Now, there are two factorial designs. One is 2 by 2, where there are two factors and two sub factors. For example, I have factor A and factor B. Factor A has A1 and A2. Factor B has B1 and B2. That is 2 by 2 factorial design. But if I want to do 2 by 3 factorial design, my A factor is A1, A2, A3, and my B factor is B1 and B2. So because it is two and three subparts of the factors, we call it 2 by 3 factorial design. Clear, ma'am?
Yes, sir. Yes, sir.
Okay. One thing more I want to clear over here: when we talk about 2 by 2 factorial design or 2 by 3 factorial design, for example, if you look into your book on page number 19, top, it's written factor A and factor B. Factor A has two sub variables and factor B has two sub variables, and then they have come up with the possibilities on each cell. For example, A1 B1, then A2 B1, then A1 B2, and then A2 B2. So these are the possibilities or the cells that can be make up by giving the combinations of those factors. uh, these are these varies in factorial design. 2 by 2 will have two levels of A and two levels of B, and but in factorial design 2 by 3, it will be three levels of A and two levels of B. Am I clear, ma'am?
Yes, sir.
Okay. Now next is the important part, which is page number 21. I'm looking into the table 2.4. There are three different studies where or three different groups where the task complexity has been talked about, the level of arousal has been talked about, and there has been the interaction of task complexity and level of arousal. Now, what does this means? This particular study talks about designing a research where I'm trying to study the task complexity and how does it affect the level of arousal of a person. Now, this high arousal, the task complexity would be divided into either a simple task or a complex task, whereas level of arousal will have low arousal and high arousal. For example, now a person who has a low arousal might do a simple task, or a person with high arousal might be able to do a complex task. Now again, I'm using a word, um, I'm using a word maybe. It varies from individual to individuals. That's what we talk in psychology always. There are individual differences, and because of those individual differences, the differences among the findings comes in. Again, the third one is the task complexity into level of arousal. Now that's into is defined as that I'm trying to study the interaction effect. Am I just studying the task complexity, or am I just studying the level of arousal? But also, when I'm drawing under factorial design, I can also study the interaction between task complexity and level of arousal. Sometimes what happens is people who have complex, who can solve complex tasks, they have low arousal as well. So we need to study those interaction effect as well. Sometimes what happens is task complexity and level of arousal, when they are mixed, when they are interacted with each other, the performance of the person can actually vary. So it depends upon how do we put our research across, how, what factors are we putting in, what kind of interaction are we looking into, what effect are we looking into, while doing a research, what participants are we looking into. Now the next is quasi experimental research design. Now what is quasi experimental research design means? The word quasi means as if, or to a degree. Sometimes what happens is it is coming from a experimental method where we studied yesterday that experimentation method, it studies a cause effect relationship. But sometimes what happens is, what if, what if this particular treatment does not affect, or sometimes we go to the doctor give us the medicine, but what if that medicine does not work? So same way, it happens in the research as well, that sometimes we try to give certain conditions, we try to do a certain experimentation where the problem of what if or as if comes to the degree. Now Mac Burney and White in 2007 defined quasi experiment is a research procedure in which the scientist must select subjects for different conditions from pre-existing groups. Now, what does McBurney says in this particular? How does he define the quasi experiment? He defined that it is a research procedure in which the scientist or the researcher must select subject for different conditions. We do put people, put people into different conditions. Do put people into different treatment. We do put people into different environmental conditions, into different experimental conditions, where we talked about two different groups. One is the experimental group and the other one is the control group. Experimental group is a group where we put the participants into experimentation conditions, and the second is the control group, where the participants are not put into the experimental group, but they are, because they are the part of the experimental conditions, therefore they are put neutral. So that is what the experimentation method also talks about. According to Bruta in 1989, all such experimental situations in which the experimenter does not have full control over the assignment of experimental units, randomly do the treatment conditions, or the treatment cannot be manipulated, are called quasi experimentation design. One important thing in a quasi experimentation design is that there is no manipulation of the independent variable. If we talk about the independent variable, it is the variable which can be manipulated. So under quasi experimentation method, this particular independent variable is not actually manipulated by the researcher. Now, under experimentation, under this quasi experimentation design method, again we have within subject designs and the within and the subject designs, which we have been talking about. Putting the people or the groups into different conditions. Now, there are few advantages of the quasi experimental design method. It says that in social science, where pre-selection and randomization of groups is often difficult, they can be very helpful in generating results for the general trends. Now, what happens sometimes that when we are doing a research, when we are conducting a research, the selection of the groups, the selection of the participants are done, as I just said before as well, that sometimes I want to, for example, if I want to do a research on people or who are only having the personality called extrovert personality, so I am just controlling my particular group, so that whatever my research focus is or hypothesis is can be done in a healthy way. Now, for example, if we try to study the effect of maternal alcohol or the external, onto the mother. For example, a woman is pregnant, and we're trying to study the effect of alcohol use on it. So over here, we already generating the results for the general trends. For example, that having alcohol during the woman who is pregnant, having alcohol might affect the health of the child. So under this particular conditions of quasi experimentation, we, as we say, what if, as if, if a woman drink alcohol during the period of their pregnancy, will it affect the birth of the child or not? you know so that is the first advantage of having the of doing the research or designing using the quasi experimental design. Next particular kind of research design is the correlational design method. Now, we talked about the correlation. We didn't talk about the correlation, but much. But yes, correlation is a method of statistics or research where it's a quantitative research method where we try to study the relationships between different variables under the study. Now, what happens sometimes into correlational research is that we study the variables, we study the relationship of one variable with the other variable, be it a positive correlation or a negative correlation or a zero correlation. The value of the correlational design or the correlational method of research design would vary from plus minus 1.00. This is called the perfect. If it's a positive correlation between two variables, we call it a positive correlation. Or if there is a negative relationship, we call it a negative relationship. Whatever the value, be it a positive or a negative, if the value comes out, the maximum value that you can get in correlational research is 1.00, which is the perfect correlation value. Perfect correlation value means that is the maximum value that you can get in the correlation. Now, the closer the value of correlation is to 1.00, the higher is the relationship between the variables under the study. If it's going away, for example, if the correlation value comes out to be 0.26, it is a low correlation between the variables that I'm trying to study. But if it comes out to be 0.64, it is a moderate relationship. So the variables can have either a low correlation or a moderate correlation or a high correlation. If the value comes out to be 0.94, it is a high correlation, because it is close to 1.00. So your value, either plus or minus, if it's close to 1.00 being the perfect correlation, the higher the relationship between the variables will be. So that is what the correlational design talks about. Now, the researcher had enough the experimental design, which we discussed in the first two units, provide the most powerful meaning of studying the behavior. Um, the important feature of experimental design is manipulation of independent variable and control of the experiment. Sometimes the researchers are interested in some variables which cannot be manipulated by the experimenter, whereas researcher does not have control over the who, what, when, where. For example, if we are interested to study the scholastic achievement depending upon the general intelligence. Now, there is a high correlation between the intelligence and the scholastic achievement. For example, there would be a high positive correlation. Higher the intelligence of the child, higher is the possibility that the child would have scholastic achievement. He would higher the intelligence of the child in academics, higher is the possibility that the child would get good marks in his exams. So in correlational design, we try to study the variables, what kind of relationship does the variable have, and to what extent does the correlational value falls into. Now, there is a definition according to Singh in 1998. He says that correlational design is one in which the researcher collects two or more sets of data from the same group of subjects so that the relationship between the two subsequent sets of data can be determined. Now, for example, I am trying to study a relationship between stress and anxiety. Now, what will happen if I have 100 participants in my in my study? So what I'll do is I'll do a research by giving the questionnaires to the respondents and ask them to fill up. And once I get the responses of all the respondents, what I'll do is I'll have two sets of scores of each participants, and I'll try to find out the relationship between those two sets of scores of each participants. Now those scores will tell me actually that whether the relationship between the stress and anxiety is high or low or moderate. So it is actually studying two sets of scores between among all the participants who are the part of the research, who are part of the study. Now, after this is association between two variables. When I'm trying to do the correlation, I'm trying to study the association. What is the relationship between the two variables? Is it a positive correlation or is it a negative correlation? Is the value positive or is the value negative? If the value comes out to be positive, I would say yes, there is a positive correlation. But if the value comes out to be negative, I would say a negative correlation. Depending upon what the value comes up, I would interpret whether the correlation is high, or is it moderate, or is it low. Next is association between two or more variables. I can study under correlation research design or research. I can study two variables, I can study three variables, but yes, it has to be two at least. I can study four variables, I can study five variables, I can study as many as variables I want to. Only the thing is that yes, I'm trying to study the relationship between such variables which are the part of my research. Now, the advantages of correlational design is they are mainly used in cases because available data makes it easy to use. It's easy research design to use because what our main assumption is, we are not looking into the effect of one variable onto the other variable, but what our aim is that we are trying to look into the relationship between such variables. What kind of relationship do they have with each other? For example, if I talk about that a relationship of a brother with a sister, a relationship of one brother with the other brother, we say that the relationship is good enough, or is it high, or is it low, or is it what. Same goes in psychological research. We try to study the variables, we try to see whether the relationship of one variable with the other variable, is it what kind of relationship is it? Is it a positive or a negative or a zero? Yes, one thing more I have just missed out is, when we say a positive correlation, it means that one variable is influencing the other variable in the same direction. For example, if my stress is high, my anxiety is also high. It means both the variables are going in the same direction, be it going high or be it coming low. One variable should have a relationship in the same direction. So the meaning of the positive correlation is that one variable influences the other variable in the same direction. That is what is positive correlation. Negative correlation, on the other hand, is defined as when the when one variable influences the other variable in the opposite direction. For example, if I say that yes, stress is affecting the commitment of the employee in a opposite direction. For example, if stress goes high, the commitment goes low, or if commitment goes high, the stress would go low. So one variable is influencing the other variable in the opposite direction. That is what is defined as the negative correlation. And the third one is the zero correlation, which says that there is no relationship under the there is no relationship among the variables under study, which means that yes, whatever I'm trying to study does not have any relationship between each other. Only happens when the researcher is not aware about the variables that he is trying to study. Otherwise, there would be either a positive correlation or a negative correlation. For example, if you do your researches in psychology in future, you would come across that the correlation, when you try to apply it onto your variables, it will either be a positive correlation or a negative correlation. There will be very less chances that you get a score or a relationship saying that there is a zero correlation. It won't ever come. It only comes when the researcher does not have the knowledge about the variables. The researcher does not know the meaning of the variables. That is the only case. uh, Yes. Next is causal comparative research design. Yes. When I'm doing a research, in correlation, I'm just trying to study the relationship. But what if one variable influencing the no one variable is causing the other variable? For example, if one variable is affecting the other variable, then I use another statistical techniques. Then we use another design statistical techniques to do the interpretation of the data. So there are two cases: either a relationship or the cause, of one variable, or effect of one variable on the other variable. So at times, the researcher also tries to study that one variable affects the other variable, or the researcher tries to study the relationship between the variables. So in either case, if it's a difference that the researcher is trying to see, or the effect that the researcher is trying to see, there is a different way of doing the interpretation. But if the researcher is only trying to study the relationship, there is a different interpretation. When you do the interpretation of studying the relationship, it's done in a different way, either a positive or a negative, or yes, either a positive or a negative correlation. But when we try to study the effect, we try to study how one variable affects the other variable. In that, we don't study the relationship, we only study the effect. Sometimes what happens is, for example, if you are studying in a room, and in that particular room, a light goes off. So what will happen? The light is affecting the study pattern of the individual. So वहाँ पर we are not trying to study the relation. We are only studying that how one variable affects the other variable. There are statistics like, for example, t-test, ANOVA, um, are the statistical tools that we use to study the effect of one variable on the other. Whereas when we're trying to study the relationship of one variable with the other, we study the correlation as the statistical tool. Okay, clear till here to everyone? Is it clear to everyone? Right. Okay, I guess we're done with today's. Any questions from anyone, please?
Hello.
Hello. Yeah.
Good evening, sir. Sir, can you please help me
Very.
on page number 38?
1 second, ma'am. Page number 38. Right.
Sir, where there are
And you.
signs of x1 and x2 of those two
Okay.
variables. So, what are those O1 and
Okay. Now,
P1?
those are the variables that I'm trying to study. No, those are not the variables. X1 and X2 are the variables. When I say O1, O2, O3, or P1, P2, P3, they are the members. Those are the scores of the participants. For example, X1 is stress and X2 is depression. So O1 is the first participant, and P1 is the first participant who has O1 is the first participants who has filled up stress, and P1 is the first participant who has filled up depression. So these are the scores that they have given. We try to see the relationship between these two.
Okay,
Okay,
thank you, sir.
most welcome. Haji, anyone else? Any other questions, please? There's a question about ANOVA. Okay, now ANOVA stands for Analysis of Variance. Now, what happens? Under ANOVA, we try to study the significant differences of the two groups. For example, let me give an example by saying that the example that I quote yesterday as well. There are students who were doing 12th boards, and I tried to see their exam anxiety because of the exams. Now, there will be two conditions: before scores of the students before I did meditation, and score of the students after I did a meditation, which means pre-test and post-test. And to see whether the meditation has given an effect, I'll try to apply the statistics over two different groups to see whether the meditation has given the effect to the students on exam anxiety or not. So that is what is the ANOVA does for. Even t-tests do the same work. Both these statistics, they try to study the significant difference between the groups. Is it clear to you, Kriti ma'am? Sorry, Kirti ma'am. Kirti ma'am. Is it clear to you, ma'am? Any other question from anyone, please? Learners, please ask some questions till I think I need to be here in another 4 minutes. Please ask if there is any question. Someone can unmute and then ask the question, please.
Hello, sir. Hello.
Hello, yes.
Sir, can you please go over through page number 30?
Hello, yes, ma'am.
There are types. So how can we go over through them?
1 second. Page number 30. Hanji, ma'am.
So there are so many types like...
Type of quasi-experimental design.
Yes, sir.
Right, ma'am. Ma'am, okay. Now, these are non-equivalent group. I'll just explain what these types are. Non-equivalent groups and control groups, or the non-equivalent group post-test only design. Now, ma'am, there can be different groups that we make. For example, the first says non-equivalent group. It means that you make different groups, but the nature of the groups are different. For example, you want to study, variables which are different, but the number of participants are similar in nature. But the number of the participants, the number of the groups, they are different, and because they are not equal in terms of the nature of the group, that is what is termed as the non-equivalent group. Okay. Now, under non-equivalent control group design, what happens is, as we talked about yesterday as well, that there are two kinds of groups that we talk about in experimentation method. One is the experimental group, and the other one is the control group. So control group is a group where though they are the part of the research, but these are the participants in the group who are kept neutral. No experiment is done on such groups. So those are the groups where the nature of the group, again, the groups can be different. So that is what is termed as the non-equivalent control group. Next, yes. Am I clear, ma'am?
Yes,
Okay.
yes, sir.
Baki, ma'am, do go like when you go back, make sure you read through, and if you find anything which you couldn't understand, you can always come back. No issues.
Okay. Thank you, sir.
Okay, mom.
Anyone? ठीक है विवेक जी, थैंक यू.
ठीक है, thank you so much, sir. Thank you everyone.